right, good day everybody. It's our pleasure to welcome you all here. My name is Professor Steve Butt. I'm currently the Discipline Chair for Process Engineering, and welcome to our open house. We have started out a formal presentation about process engineering. Several professors are speaking, several students. We'll follow that by a lab tour and come back there for a general open house to meet the remainder of the faculty and staff and to have some food, basically some pizza and some drinks. We'll get started. I'd like to introduce Dr. Kelly Hobbold and Dr. Leslie James, who's going to give a formal presentation on process engineering, and they'll also be inviting some students to participate as well. Please proceed. Thank you.
Okay, so it's actually not that formal, so don't be too freaked out. It's not that formal, so don't be too, that didn't sound very natural at all, Adrian, but I'll try. Right, so all we want to do is give you an idea of what process engineering is about, because some of you might think, not quite know what the term is. It's probably most closely aligned with chemical engineering, and it hits all the things that chemical engineering does, but I think it does it a little better in that we focus in on the actual unit operations or parts of a process in a big refinery or mining facility or petrochemical or biofuels. So it's chemical engineering. It includes mineral processing and extractive metallurgy. That's kind of our focus here. It also includes petroleum engineering and refining. That's two of our major focuses within process, and Dr. James is going to talk a little bit more about that. It includes things like food processing and biotech, so I tend to work more on biofuels and environmental, so I tend to hit more on either the waste side of those things or the biotech side of the things. And it's a lot of materials engineering, and that covers the whole gambit from refining through to reservoir engineering, through everything. So you see all of these things covered off in process engineering, which makes us probably, and even my PhD mechanical brother, he is a human, mechanical engineering brother agrees with this, that process or chemical engineering, and probably you can work in any field. Anywhere there's a process or they're making something, there's a chemical or process engineer. And it has the set that, so next to mechanical, it's probably the most diverse, I would say more so. All right, oh, so yeah, there's the answer, if you were all at all worried about what the answer was. All right, so it's the newest program here at MUN. We were accredited in the Faculty of Engineering in June 2013. What accredited means is that when you get your degree, you can actually become a professional engineer. That was really important. The other thing about that particular accreditation process is they were so impressed with the program that in most new programs, they just give you a 2 or 3 year, saying, okay, here's 2 or 3 years accreditation, then we'll look at you again. They were so impressed with our program, they gave us the 5-year program, so we don't have to be accredited again for another 5 years. So it said a lot about the program. We focus in this program on natural resources because Newfoundland and Canada is full of natural resources, but we're not always extracting them and processing them in the most sustainable or most probably environmentally friendly way. So we emphasize green engineering and sustainable extraction and the development and utilization of the Earth's resources. And I'll get a little bit more into what I mean when I say sustainable or green processing in a second. All right, what does sustainability mean? There's the official description of sustainable development. You try to balance the fact that society has needs, the fact that the environment has needs, and the fact that you still have economic constraints. You try to balance those all. And then you try to not deplete your natural resources beyond the abilities of the Earth's ability to actually supply them. And right now, we're outdoing the natural resources and the ability of the Earth's ability to supply them. So we have to try to do our best when we extract and process natural resources that we try to make things as energy intensive as possible, meaning we're conserving energy and using sustainable energy sources, etc., minimizing waste streams, and basically just have an overall process-intensified process. I hope you got that one on tape. So we, as engineers, have a really unique ability, especially process engineers, is that we can get right in on the extraction, right from the reservoir where Dr. James works, right into the process where you might process the oil to usable products, right to the fact where we design the systems that might use those products. We have the ability to change or alter those processes so we minimize our waste outputs and also minimize our energy inputs. And that's the whole focus of this program, is trying to make a process better or more sustainable. And so that's what I'm talking about. Natural resources we use, how we use the energy to produce it, etc. Why even incorporate green principles? Because we're running out of natural resources. You can say that, yeah, we have lots of tar sands and everything else, but those are unconventional resources. We're running out of the conventional stuff, and so we've got to come up with ways of either converting those unconventional resources into something sustainable, or because it's not one or the other. Petroleum is not going to go away tomorrow, but incorporating other types of, let's say, energy use. That's just one example. Energy is one example. Using other types of energy like biofuels or renewables in with what we're already doing as far as energy use. That's just one. So water shortages is a good example. Usually you have water shortages not because you don't have enough water, but because the quality of the water is so crappy and you can't clean it up well enough for people to drink and use. We look at local and global impacts. So sometimes we feel impacts more locally. Anybody who's lived in Calgary, Toronto, Houston, Beijing, knows that smog's a huge issue, but that is a really local pollution problem. There's other global pollution problems like greenhouse gases, etc., that we emit here, but that are carried all over the world. Persistent organic pollutants is a perfect example. We produce a lot of it here. Most of it ends up in the Arctic because of the way our winds work, etc. So that's the whole point of green engineering. Some of the examples, this is my last slide. And this is just some ideas of where these are actual chemical engineers working in these areas. One is textiles. Shaw Carpet basically looked at their entire, he's okay. So maybe we'll check on him later. But Shaw Carpets, not now. Shaw Carpets basically looked at their entire process and said, how can we do this so we're actually not producing anything toxic? And the most toxic thing they had was that little rubber stuff between the carpet and the floor. So they just developed a material that was less toxic and produced it in a green and sustainable manner. And then there's other ones, Ford and Dearborn, they basically converted the roof of their manufacturing facility into a green area and used polluted soil to actually feed the plants, because plants and bacteria are really good about breaking down organics. So that's kind of giving you the big picture of what we're looking at in green engineering. And then Dr. James is going to give you a breakdown of what the courses look like.
Yep. So here's a summary slide about green engineering and sustainability. So again, I mean, everything Dr. Hobalt said is that we have to be able to balance our need for social progress. We wouldn't want to have to go back to using slide rules instead of calculators. Would anyone like to give up their smartphones? I don't think so. With economic growth, but at the same time, we need to make sure that society improves overall and from an environmental perspective. So there's a real balance. Before we get into the next part, the other core principle of our process engineering program here at Memorial is also safety and risk. Okay, so there's a large element of safety and risk engineering, which is another unique factor to our process engineering program. The sustainability and the safety and risk focus make us unique across Canada, and these two pillars are things that you don't get in a traditional chemical engineering program. Okay, to the point where some other chemical engineering programs across the country are wanting to switch into a process engineering program. Okay, so safety and risk, everything we do has a risk associated with it. You took a risk by driving your car to school or trying to cross the crosswalk here on campus, okay, to get into this building. So what are the risks associated with an activity, and how do we minimize them so that we carry out our industrial process, our process engineering, in the safest way possible for, again, the people that are working in the plant or near the process, the public at large, animals, and the environment. Okay, so it's not just safety and risk for the workers, the occupational health and safety, it is for the local and global community that we would impact. Okay? So, what is process engineering? Okay, process engineering, you will start off obviously in your first year with your general first year. Going into term 3, you will take your chemistry, and then you will take one course, Introduction to Process Engineering, that I teach. And before we finish, I will ask, there are other undergrads here that just took it in the fall and took it a while ago, and they will be able to comment on that as well as the program in general. Okay, so we can, as you go through the program, you're going to take some courses that are similar to mechanical engineering, like your fluids 1 and 2 and your heat transfer, and of course your math. Okay? You will then take process-specific courses like mass transfer, like reactions. So now you're going to take the little bit you learned about your stoichiometry and everything from chemistry and apply it to industrial scale reactions. Okay? And the different types of reactors we actually use in industry. So Dr. Hubble teaches that course. We then have process equipment 1 and 2, where you're learning all about the equipment and the theory behind the equipment that you're actually introduced to in term 3. Okay? So we're taking a real top-down approach in process engineering, which is different than most programs in Canada as well, where in term 3, that introduction to process engineering, you're actually learning how to design a process from start to finish, all the equipment that's required in between, because again, process engineering is the transformation of a lower value natural resource to a higher value good. Okay? So we can think, and one of the tours we've done in the past is going to Central Dairies, where we see the transformation of milk, right, and that pretty natural product straight from the cow, into cheese. Okay? So that's a really good food engineering example, because we can all relate to food. So you're going to learn essentially the overview of everything you need to learn in term 3, and then for the rest of the program you get into the details. So with process equipment 1 and 2, like I said, we're into the theory of the actual equipment. You get to be part of the best lab across Canada for process or chemical engineering, because we have by far the best lab compared to U of T, compared to Waterloo, compared to McGill. It doesn't matter. That is the best lab next door. Okay,
We've got a chance to see that.
Yes. So we've got lab scale, real equipment that you can play with and play with the parameters. Plus you get us as professors. So there's Dr. Aziz Rahman, Dr. Imtiaz back in the back, or Salim, sorry, in the back, myself and Kelly, Dr. Butt. Who else is here in terms of profs? We got our
Sheriff is just outside the door.
Okay, we got our 2 technicians, Kelly and Brett, here in the back that run the labs. And so really you're getting access to the best program, the best professors in terms of how accessible we are and how much we actually care for how our students do. And you guys better attest to that in the back. And the best labs in the country, okay? So that's our program in overall. We've got our regular process stream, and starting in this fall, so the fall of 2014, we are introducing a petroleum stream to process engineering. So for anyone who's entering term 6 in the fall of 2014, or you're behind that, so all of you guys, you'll be able, if you're interested, to take the core process stream or a petroleum stream, where the focus is more upstream petroleum engineering. And I'll get into what that means after. So, the careers, co-op, and employment opportunities. Before we get into the actual different careers that we can partake of as process engineers, I want to talk about co-op for a minute. Okay, because I've already heard rumors that a couple of you are concerned about getting co-op opportunities if you went into process engineering. Okay? That, in certain terms, in certain years, getting your first co-op, and I'm not talking about your year one co-op, I'm talking about after your term 3 really, is challenging. Okay? Absolutely. There were a lot of unplaced co-ops for this term. But the university is working very closely with all of industry to maintain relationships with industry and create as many co-op jobs as possible. Okay? As a safeguard, guess what we do as professors? We will give you opportunities as well. Now we can't give everyone, but to have co-op jobs with us working on our research projects. Okay? So we're committed to helping as many people as well find co-op job placements. So at the end of the day, while process engineering was new and maybe the very first class had some difficulty getting their first work terms, guess how many of them ended up with full-time jobs before they even finished their program? 2/3 of the class, and there was 36 or 38 people in that class. Okay? So the first one is challenging, irrespective of your discipline, but it gets much better with time. Okay? Now, what kind of jobs can you actually do? So in mining and metal processing, we're talking about now transforming our rock that has the mineral into it, or in it, into a metal that can be used. So let's take nickel, for instance, since we have nickel in Labrador. We don't get, everything they're mining up in Boise Bay is not 100% nickel, okay? There is maybe at maximum 40% nickel in that rock. So they have to take the rock, they have to mine the rock, and now they'll crush it to a certain size, and soon they will be transporting it down to our valet processing plant here in Long Harbor. And then how do we get the nickel out? Okay, because remember, there's only maximum 40% nickel in that rock, and that's the super high concentration. So one of the things you'll learn as process engineers is that milling, creating a larger surface area to volume, is really important. So instead of trying to get the nickel out of a big boulder this size, if we make that nickel or that rock into a powder, now we can access the nickel much more readily. Okay? So usually size reduction is a huge step in process engineering. Then we're going to process it. Okay? And the valet processing plant in Long Harbor is the first commercial scale hydrometallurgy process in the world for nickel extraction. Before that, up in Sudbury, they use smelting. So they essentially burn it and create a lot of air pollution. Okay? We're now using a really high-tech process of essentially dissolving some of the nickel and using electrostatic precipitation to actually get the nickel out of solution and turn it back into a solid in its pure form. So it's super cool, it's super high-tech, and it's the only place in the world that's doing it so far. So that's really impressive. So then we got our pure nickel. We also have waste streams, right? And we also have some other precious metals and everything in there. So from a sustainable point of view, how do we minimize the waste? How do we reuse all that water? Because it's a hydro process, meaning water-based process. And, how do we extract the small amounts of gold and silver and other precious metals that are also found in that rock? Okay, so that's part of the sustainability. What I also thought was really cool is that rock without the nickel in it actually is put back on board the ship and used as ballast and will be sent back up to Labrador to fill in their open pit mining sites. So I thought that was really cool because ultimately we have to put back that mine site when we're done, and it has to be put back to the way it was found, obviously minus the nickel. Okay. Now, what's nickel used in?
Nickels?
Nickels.
I can't believe not one of you came up with that.
It's also used as an alloy, right? So it's put into our steels and our higher grade alloys like Hastelloy, etc. as well. Okay, and you'll also find nickel in a lot of your solid state electronics. Okay. So actually, the engineering is part of it as well. So you could actually work, not directly for Vale or the mine itself, but you could work in one of the downstream companies that is actually taking that nickel and making the alloys or making the actual goods. Okay? Oil and gas. So my main focuses are on these two, and I'm actually going to ask Kelly to step in for the bio slide when we get there. Okay, oil and gas. It's found underground. It's not found in a big tank underground, like I first thought it was when I started my master's. It's actually inside the pores of a rock. So you know how water runs through sand? Well, you got to think of the sand now being actually consolidated together, more like a concrete. And inside the pores, in between those grains of solid, is where we get our oil and gas. But it's anywhere from a few hundred meters to a few kilometers underground, and possibly under the sea. So how do we get that out? Okay, how do we find it? How do we get it out? How do we produce it? How do we bring it up to the platform itself, be it onshore or offshore? And then, how do we bring it to the refinery? Come by chance. Have you all driven by Come by chance or refinery, where we take that crude oil and we break it into different fractions. Everything from our butane, our propane and our butane, to our hexanes, to our octanes, which is mostly gas, and the other aromatics, okay, all the way to the crude oil, or to the bunker C. So we'll take that crude oil and we'll make a whole bunch of different oil products, okay, including vacuum grease that we'll actually use to lubricate some of our engines. Okay. So out of that 1 barrel of crude oil, the refinery, actually most of it, 60% of it will go to diesel, and then other smaller fractions to some of the other components I just mentioned. Okay. And how that works, the theory by which you separate the crude oil into those different components, how you do it efficiently and sustainably, you will learn in process engineering. Okay? If you take that petroleum stream, you will also learn how the geology and the exploration works, and how the reservoir engineering, how do we get that oil and gas to flow through the rock to the well? How do we get it? How do we drill our wells? That's Dr. Butt. How do we produce it on the platform? All of that you'll learn in more detail if you do the petroleum engineering stream. Okay. And then ultimately, once we get those different components, and our gasoline and our diesel and our fuel oil, then we have to worry about getting it to market. So as process engineers, you can work in any or all of those sectors over your lifetime. Okay. Any questions about mining and mineral processing or oil and gas?
You'll have an opportunity after the presentation, after the tour, to speak with background.
Okay. So the food industry, I think we already touched on this, but like I said, it can be milk to cheese. You can work at the McCain's French fry plant up in New Brunswick. They also make pizza pockets, and I got to taste one before it was even frozen back in the day. And any processed food, okay? So sugar, coffee, mac and cheese all require process engineering, because we're going from raw or lower value goods to higher value commodities. Not that you think, so you think about the economics involved in being able to sell a box of Kraft dinner for less than $1 a box. Okay? So they must have to make an awful lot of it, and we know they do, to be able to get those economics to work. But those are just some of the foods that we are actually touch as process engineers. So if you think McCain's, you think Procter & Gamble, you think Kraft, there are 3 huge companies that you could work in if you were interested in food engineering. Okay? Biotech, back to you, Kelly.
Okay, so just like to follow up from Leslie's discussion of petroleum, petrochemicals, all the products from, or a large percentage of the products from a come by chance will also, that are not fuels, go to a petrochemical facility and produce plastics, produce this fine quality, whatever that is. But, so the petroleum industry feeds more than just our energy. It feeds most of the synthetic products that you see around you.
Yeah. And I'll
So-
jump in. Rayon, polyester in your clothes, fleece, all your shoes, bags, everything, plastic, right? Cell phone covers. Yeah, sorry.
No problem. So biotech is, it covers a huge area. It's everything from biofuels, biopharmaceuticals, biomaterials. It'll cover it all. In our particular focus, at least in my research, so it's really all about me, we try to, you can either take virgin biomass, so that would be, if you think of when people grow corn, and the ethanol industry has a subsidy, they grow corn, they use the corn to produce ethanol. Really inefficient way to produce ethanol to blend with your gasoline, because you're using a food crop. That's not what you want to do. What you'd rather do is produce the corn, and then take the waste that you produced when you produced the corn, the stover and all the husks and everything that, and convert that to bioethanol or some kind of fuel or some kind of biomaterial. So it covers biofuels, fuels derived from biomass, forestry residues, fish plant waste, virgin, as I said, food crops like sugarcane and molasses, etc. Biochemicals, those are chemicals derived from biomass. So the idea is that instead of having a come by chance refinery, you'd have a biorefinery where now your feedstock, instead of it being crude oil, it's forestry, it's all these other products, and produce the same chemicals, because they all contain the same chemicals. It's just a matter of how you extract them. And that's where it's amazing the similarities between a come by chance and how you might build a biorefinery. But it's all built on the concepts you learn in process engineering. Mass transfer, heat transfer, reactions, it's extractive type, separations, those sorts of things. Biomaterials, there's a huge area of research and actual work into shingles, insulation, fiberboard composites a lot, et cetera. So a lot of the composites and materials that you get right now may be 50% synthetic chemicals from a petrochemical facility, and the other 50% might be biomaterial resource. And then biopharmaceuticals, which is what I did in my master's, and that's where you use antibodies, bacteria, and viruses to produce, you use bacteria, viruses, etc. to produce, and mammalian cells to produce antibodies, vaccines, those sorts of things. So you always think of just biochemical people there. No, they have to scale it up. If you're going to produce it for a pharmaceutical company, working in a petri dish is not going to work. So that's where the chemical engineer or process engineer comes in. They say, that's really cute. Your petri dish is really cute. Now let's scale that up, shall we? And that's what we do. We take it and we scale it. So we work with the chemists, we work with the biologists, and we say, great idea, I can maybe work with that and work it so that we've got lab scale, pilot scale, and now we're industrial scale.
So, if we look statistically at where you might end up if you chose to do a process engineering degree, 45% of you, if you all did process engineering, might end up with a large resource company. Okay? That's because typically process engineering requires a lot of capital. These are capital intensive processes. These are large scale processes where, not everyone can have one pretty much in their backyard like a little mechanic next door. Okay? So 45% will join large companies. Exxon, Chevron, Husky, Suncor, in terms of some of our operators, Statoil. Vale, we've got that does our nickel. We've got Rio Tinto, which is now the iron ore, has taken over our iron ore Canada company up in Labrador. We've got service providers, so all the people that actually work with these large owners, so the Schlumberger, the Technip. So here's more of our engineering consulting, our service providers, the Halliburton, etc. Okay. 35% of you might join a government agency or an actual consulting firm. Okay. So we've got smaller consulting firms, local consulting firms, like Penacon Technical Services or GJ Cal. And then we've got larger, cross-Canada ones and even multinational. So like Floor, Peter Hewitt, the Wood Group, okay, which has bought out PSN, etc. So the type of job you would do, whether you're in the actual owner company or whether you're in the service provider or the consulting company, is going to vary, okay? Because if you're with one of the large resource companies as an owner, you're making sure, you're potentially making sure that you're optimizing the process, that the economics is working out, so what you're producing and what you're selling, the whole economics is working, or if you want to do a major upgrade or expansion, what does that entail, etc. If you're with the design and consulting companies, you're actually probably working on, okay, what are the details of what that expansion or upgrade looks like, okay? I need to design a tank to be able to hold 100,000 barrels of crude oil, etc. So here you're going to be working with the companies. You'll probably, if you're with the design and consulting firms, obviously be doing more design work than you would if you were with one of the owners. Okay. As a government, working with the government, you are probably looking out for making sure the owners and these consulting companies follow regulations, and that the industry in general is following all the regulations required for the environment, water and oceans, industrial standards, etc. Okay, so you're going to be making sure that we're managing our resources properly. So Department of Natural Resources here, or the Canadian and Newfoundland and Labrador Offshore Petroleum Board, so more on a regulatory side. 10% of you might go on to graduate studies in engineering. Jared and Danica in the back, they're graduating this year and they're going to do their master's hopefully. Okay, and Mark, sorry Mark. Sorry. Okay, and then 10% of you might go on to actually do something besides process engineering. Because guess what? Engineering in general teaches you to problem solve, and you're goal oriented. So it is a great background if you're interested in medicine, law, human resources, anything else. I know, people I graduated with have gone on to do all of those things. So just because you might choose process engineering now, it doesn't mean that's what you're going to do forever. I didn't think I'd ever become a professor, and here I am. Okay, so I already had one career before becoming a professor. So it's okay to change, but the good thing to know is with an engineering background in general, and especially a process engineering background, you really understand how it takes often multiple steps to go from A to B. If you would like more information about process engineering, you can. Please come by the back hall in this building and see any one of us. Okay. Dr. Butt over here is our discipline chair, so you can contact him. And certainly the general office over in the SJ Crew building, if you don't know where to find us or Dr. Butt, go into the general office and they'll help direct you. Okay. We also have our website, and we should have a couple of more of these information sessions if you would like more information. The other thing I will also encourage you to do is talk to the upper year students. Okay, so everyone that is upper year here and chosen process engineering, can you guys raise your hands? Okay, so we got some that just finished term 3. We got some that you're finished term 5.
We're in term 5 now.
You're in term 5, and then we got some term 8 students that are graduating in April. So you don't have to take our word for it. Now's your chance to ask them what they think. Now they've all been brainwashed, but yeah. Okay. So here's your chance. As a student in process engineering or other engineering disciplines, there's also a great chance to get involved. Besides Engineers Without Borders and Paganel, and we have some specific professional student body groups. 2 process engineering, and one of them is the Society of Petroleum Engineers, the student chapter, and the other one is the Canadian Institute of Mining student chapter. and the Canadian Society of Chemical Engineers, which has a great conference every year that you could get to go to. Okay? So, questions before we go on the tour and have pizza? One that is currently offered in mechanical is changing as well. So the process one is more aligned with the old oil and gas stream in mechanical engineering, where you will do your courses in petroleum geology, reservoir engineering, well testing, and you will do your senior design project, your 2-term senior design project will be oil and gas specific. Okay, it's an option. It will be an option, so it will say on your transcript that you have done this option. Mechanical is going from an option into a stream. So they're going to have several streams that you can do, where you have more choice to mix and match what those electives are. But at the end of the day, it will not say that you've completed an option on your transcript. Okay? And your senior design project is still going to be mechanically focused, like the general mechanical design project, as opposed to an oil and gas specific one.
Yeah, and let's be clear, all the oil and gas programs taught mechanical are taught by the process
Yeah.
engineers.
So they're taught by Dr. Hobalt, myself, Dr. Thorman Johansson, and Dr. Buck. And I think
And Yan.
Yan is there, Dr. Zhang,
Aziz.
yeah, and Dr. Rahman, who just started, is starting to teach in that as well. So every faculty that is teaching those oil and gas courses, or the fundamental oil and gas courses, are taught by process engineering profs.